Hi everyone, this is Practice Formative, Chapter 3, question number 20. So in this question, we need to find generated volume in terms of pi when the shaded region is rotated through 360 about the x-axis. So we have to spin around the x-axis. Therefore, the formula will be pi integrate with respect to x. The subject must be y squared. So the boundary will be on x-axis. So this will be the formula, okay, when we need to find the generated volume that is rotated about the x-axis. Okay, now, so first part, we have the boundaries 0 to 3, so we can just apply the formula right away. So the volume generated will be pi. The lower boundary is 0, the upper boundary is 3, and then square the y. So we have x squared plus 2. We got to square this part so that we can integrate with respect to x. So now let's expand first. So we have x to the power of 4 plus 4x squared plus 4 dx. And now we integrate this. So x to the power of 5 over 5 plus 4x cubed over 3 plus 4x. And we got to put the boundary, the lower boundary and the upper boundary. Now we substitute the upper boundary into the integrated expression. So we have 3 to the power of 5 over 5 plus 4 times 3 to the power of 3 over 3 plus 4 times 3, that is 12. And then minus when we substitute the 0 into the expression, we got 0 here. Okay, so with this, we need the help of calculator. Okay, so we shall take 3 to the power of 5, 3 to the power of 5, okay, over 5, plus 4 times 3 cubed divided by 3, so we have 3 squares, so 9 plus 12. Therefore, the answer is 96 and 3 over 5. 96 and 3 over 5 pi unit cube. Okay, so that's it. We found the volume generated for A. B, okay, same thing. We have to use the formula pi y squared dx. So the y squared is 4 plus square root of x. Got to square this expression towards the x-axis, and the boundary is from 4 to 9. So let's expand first. Okay, we expand the expression here. 16 plus 8 x to the power of half. Okay, change to index form. It's easier for us to do the integration later. And then the plus x dx. And now let's integrate this. We have 16x plus 8x to the power of, increase the power by 1, so it will be 3 over 2, divided by the new power, 3 over 2. The denominator of the denominator will become the numerator, plus x squared over 2. And then integrate from 4 to 9. Don't forget there is a pi in front, okay? Now let us move on. We have to substitute the boundaries into the expression that we just found. So we have 16 times 9 plus 16 over 3, 9 to the power of 3 over 2, and then plus 9 squared over 2 minus 16 times 4 plus 16 over 3 times 4 to the power of 3 over 2, and then plus 4 squared over 2. Okay, so we need the calculator to help us to simplify the calculation. Okay, so with this, I will key in the integrated expression. So 16x plus 16 over 3 times with x to the power of 3 over 2 times with x to the power of 3 over 2. And then plus x squared over 2. X squared over 2. Okay, set the formula in the calculator. So now we put in 9, the upper boundary. We got 328.5. 328.5 minus, when the 4 is substituted into the integrated expression, we have 114 and 2 and 2 over 3. 114 and 2 over 3. So this one, let's find the difference. So 328.5. 328.5 minus 114 and 2 over 3. So we have the answer 213 and 5 over 6. Okay, 213 and 5 over 6 pi units cubed. Okay, so that's it. We found the answer for part B. Now, let us move on to part C. Let's look at part C. When we generate the volume, okay, that is to spin the shaded region about the x-axis through 360 degrees. So over here, basically the area below the graph consists of two parts. One is from the curve, and another one is from the straight line. So this one we have to find the volume generated for these two parts separately. So for part C, we have to find all the x-intercept. Okay, so for the curve at x-axis, we know that y equals to 0. Therefore, x squared plus 6x plus 9 equals to 0. And this one, if we factorize, we will have x plus 3 squared equals to 0. Therefore, x equals to -3. So we found this one to be -3. And then what about the straight line? So for the straight line, at x-axis, y equals to 0. Therefore, 3 minus x is also equals to 0. So x equals to 3. Okay, so we have 3 here. Next, we need to find the point of intersection between the curve and the line. All right, so for that, we take y1 equals to y2. So let me just label, this is y1, this is y2. Therefore, we have x squared plus 6x plus 9 equals to 3 minus x. So bring this over to the other side. So we have x squared plus 7x, 9 minus 3, positive 6 equals to 0. Therefore, when we factorize this, we will have x plus 1, x plus 6. Therefore, x equals to -1 or -6. Now over here, -1 is the answer because -6 will be on the left side of the -3. So over here, we already got the x values on the x-axis. So now we can start to generate the volume. So how do we generate the volume? So volume will be pi. So for the curve, we integrate from -3 to -1 towards the x-axis. Therefore, y squared. So we got to square this. Now, instead of using this, I will choose to use this one, okay? Because y can be written in this, the vertex form, after we complete the square. So square of x plus 3. So if we want to use, okay, y1 squared, okay, to plus with integrate -1 to 3 y2 squared, that means the y that represent the straight line. Okay, so let's put the y1 squared in. So the y1 is x plus 3 squared. So when I square this, I will have x plus 3 raised up to the power of 4. Okay, likewise, -1, 3. The y2, we need to square it. That will be 3 minus x. We square this part, dx. Okay, so for each, we now integrate. Okay, so increase the power by 1 and divide by the new power and divide by the coefficient of the x. All right, so for this, we have to integrate from -3 to -1 plus with 3 minus x raised up, add 1 to the power. So we have 3, then divided by the new power and divide by the coefficient for the x. And for this, we have to integrate from -1 to 3. Okay, now we substitute the value in our integrated expression. So over here, we have -1 plus 3 raised up to the power of 5 over 5 minus -3 plus 3 over 5. Okay, and then for the second term, we will have 3 minus 3 over -3, okay, cube the numerator, minus 3 minus -1, so 3 plus 1, cube over -3, so we plus here. Now, -3 plus 3 is actually 0. So for that, this whole thing is 0. And 3 minus 3, this whole thing also 0. So what we're left with will be pi. So 3 minus 1, 2. So 2 to the power of 5, which is 32 over 5. And then we plus with this. 3 plus 1 is 4. 4 to the power 364 over 3. So let's add these two together. So with the help of calculator. So we have 32 over 5 plus 64 over 3. Okay, so we got the answer. 27 and 11 over 15. 27 and 11 over 15 pi unit cube. Okay, that's it for the question part C. Right, so for part D, in order for us to find the volume generated when the shaded region is revolved about the x-axis, okay, through 360 degrees. So we have to use, again, v equals to pi and then y squared dx. Okay, this is the one that we need to use. But the issue now is we have two graphs. So how? So we shall take this one, y1, okay, because this is the graph above and the graph below. So this is y2. Let me just call this y2. So before that, we have to find this one, okay, because this is where if I integrate the straight line, I will have this whole thing. I will have the green shaded region. So in order for me to get the gray shaded region, I have to minus the area under the curve. Therefore, isn't it we have to find the area, use the y1 minus the y2. Okay, therefore, it will be like this, y1 squared minus y2 squared dx. Okay, and then what is the boundary? So the boundary will be the intersecting point here. So we have to find this one. But do we know the function of the straight line? We can always find, because according to the linear graph, so y equals to mx plus c. The c here is 9. The m will be the height by the base. Okay, the height by the base is going uphill, so our m is 1. Therefore, y1 is x plus 9. And then y2 is x plus 3 raised up to the power of 2. Okay, therefore this is -3 here, but not important. The most important thing is the point of intersection here. So this is where y1 equals to y2. So y1 is x plus 9, y2 is x squared plus 6x plus 9, and x squared plus 6x, bring everything over, plus 9 minus x minus 9 equals to 0. So we have x squared plus 5x equals to 0. So x times x plus 5 equals to 0. So we have x equals to 0 or x equals to -5. So this point here is -5. So we need to integrate from -5 to 0 of the upper graph minus the lower graph, because that will produce the shaded region. Okay, the shaded region, the gray shaded region. And then from there, go through this formula pi square of the function just now. With respect to x, we will get the volume generated. Okay, so let's just put the y1 in. So the y1 is x plus 9 squared. So we're going to minus the y2. So x plus 3 squared, and you square again, so 4 dx. Okay, so this is two different terms. We have to integrate them separately. So pi, so x plus 9 raised up to the power of 3 over 3 divided by, and also divided by the coefficient of x, and minus x plus 3 raised up to the power of 5 raised up to the, and divided by 5, as well as the coefficient of x. And for this two, integrate from -5 to 0. So let's substitute the 0 in. So pi 9 to the power 3 over 3 minus 3 to the power 5 over 5, and minus -5. When we put in, we will have 4 to the power 3 over 3 minus -5 plus 3. So we have -2 raised up to the power of 5 over 5. Okay, so with this, we need the calculator to help us. So let's put in the 9 cube minus, okay, 9 cube, 9 cube. 9 cube over 3 minus 3 to the power of 5 over 5, and then minus 4 to the power of 3 over 3, and then minus the -2, -2 raised up to the power of 5 over 5, close bracket. Okay, we got 166 and 2 over 3. 166 and 2 over 3 pi unit cube. Okay, so that's it for the volume generated for the question D.